Okay, moving on to example 4 on chapter 5.2. They're asking us to evaluate an integral, and they want us to interpret it in terms of areas. So what I want you to understand about these integrals is that the answer to this problem is the area under the curve on the positive part of the x-axis. If it gets below the x-axis, it's a negative value. And it represents areas. So if we look at the equation y equals negative x plus 1 is what we would be established here. And we're going on the interval from negative 1 to 2. So just using the same principles we did with the first three examples. This is the equation. This is the x interval that we're dealing with. But now we want to actually graph this in order to establish what this looks like. This basic graphing technique. X, y, start at x equals negative 1. Negative 1, change the sign, positive 1 plus 1 is 2. If I did 0, negative 0 plus 1 is 1. If I did 1, negative 1 plus 1 is 0. If I do 2, negative 2 plus 1 is negative 1. So we can get points like that. You can do slope-intercept, method of graphing, y-intercept of 1, slope of negative 1 over 1. Take your pick. My graph paper there is big enough to fit all these on there, obviously. 1, 2, 3, 4, 5, 6, 7, 8. We actually go up to a 0.25 scale on the y-axis. And here's 2 and here's negative 1, maybe negative 1 there. Maybe a 0.25 scale on the x-axis would be legitimate also. So if we do that, negative 0.25575, negative 1, 0.2515751, 0.255752. There's negative 1 comma 2. Oh, yeah. And then 0 comma 1, 0 obviously, and then 0.25, 0.5, 0.751. 1, 2, 3, 4 over is 1, and then 1, 0, and then 8 over would be 2, and negative 1 would be down here. So those 4 points there would lie on this line. If I go ahead and draw the line, or let me just do a segment here, since we're starting at negative 2 and ending at, or sorry, negative 1 and ending at 2. So we're only really looking at that line segment instead of just the whole line. Alright, so what you need to understand here to get an idea of what we're trying to find here is if I start here and go straight down to the x-axis and stop, and then I can go all the way across here, this is a triangle that's being created. So this is our leftmost boundary created by this interval, and then the x-axis is always a boundary to these. So what I'm looking at is part of this graph is going to be this triangle here. We want to find the area of that triangle. That triangle's above the x-axis, so it's going to have a positive area. Similarly, over here, the end part of my interval is positive 2, so I want to go from my graph to the x-axis, and then go from the x-axis along there, like so. This part here is also part of the interval that we're dealing with, and it also creates a triangle which is underneath the x-axis, so its area will end up being negative. So we're trying to evaluate this integral. That's how we need to imagine this. I'm going to just shrink that down just to make it a little smaller so we have room to write stuff. So if we take a look at this blue highlighted triangle here, I'm looking for the base and height of the right triangle. You can see it's a right angle there, obviously. And again, remember we're on a 0.25 scale, so we're going 1 to the left, 1 to the right, so that's a total of 2 spaces across for this dimension. And then, of course, we can see the height for that negative 1 is 2. We can also count it up. There's 1, there's 2. So that's a 2 by 2 triangle. And then over here, this triangle, 1 space to the right, there's a right angle, 1 space down. So that triangle's dimensions are 1 by 1. So if we look at the two triangles, I'm going to go A sub B and A sub Y for blue and yellow. So A sub B is going to be 1/2 times 2 times 2, which is equal to 2. A sub Y, the yellow triangle, is going to be 1/2 times 1 times 1, which is 1/2. And again, the yellow triangle is underneath the x-axis, so it's actually going to be a negative 1/2, where the blue triangle above is going to be a positive 2. So my integral that I'm trying to evaluate is simply going to be equal to the sum of these two areas. And when I say sum, 2 plus negative a half, we're imagining signs involved. We either add or subtract based on sign. 2 minus a half is going to be positive 3 halves. So 3 halves would be the answer. And again, what we're going to do is graph. Always go from the graph straight to the x-axis, either down, up or down, whichever way it takes. And then the other dimension is just the x-axis through the interval from -2 all the way to 1. Or sorry, -1 all the way to 2. And then, again, you just look at the figures created. There's a triangle, there's a triangle. Triangles have area formulas. For a straight line, the only two shapes you're going to get are going to be triangles or trapezoids. And just in case you do get a trapezoid in your homework, this is how you handle a trapezoid. I'm not going to make an equation up, I'm just going to draw a trapezoid. So imagine let's just go on a 1-to-1 scale here. So x is at a 1 scale, y is at a 1 scale. And let's just say I'm starting here and ending up, let's say over here somewhere. So let's say I graph my two dots and that's what I get, is that. Again, we're looking at line segment, not line. So if I'm looking at this line segment starting at x equals 2 and going to 3, 4, 5, x equals 6 is the end. So basically whatever the equation of that is, it doesn't matter what the equation is. But if I did have an equation that created this graph right here, starting at 2, ending at 6, so 2, 3, 6, 4, and I'm trying to find the area under the curve, which is going to be the integral, and I draw down to the x-axis from both endpoints, I'm creating this trapezoidal shape. And there's two ways to handle a trapezoid. Method 1, that's a rectangle below this, and that's a triangle. Just add them up. We'll call that the less efficient way. The more efficient way is the two parallel sides are the bases. So this one's 3, 1, 2, 3, 4. That one's 4. And the distance between the bases is the height, 1, 2, 3, 4. All right, and I'm going to use a different color here to establish what 4 is which. So let's make this 4 green. All right, so the trapezoid area formula looks like this. Area of a trapezoid is equal to 1/2 the height times base 1 plus base 2. Looks a little bit complicated, but it's just half the sum of the bases times height, just like a triangle is half times base times height. So looking at our trapezoid here, it's just going to be 1/2 times the height 4 times the sum of the bases 3 plus 4. So this 4 is that for the height, the distance between the bases, the 3 and the 4 are these two bases. So half of 4 is 2, 3 plus 4 is 7, 2 times 7 is 14, so that area, that would be 14. So again, if you get a problem that would create that picture, you find the area of the trapezoid. Again, straight lines either make triangles or trapezoids. And again, if everything's above the x-axis, you only have to find one area. When it crosses the x-axis, so sum's above, sum is below, find the positive area, find the negative area, add them algebraically to get the overall result.